Good morning, friends. Today we will discuss about advanced foundry technology. I was worked there for Baghdad University for 2 years. So that time I have prepared for this course content for their MSc Mechanical Engineering student. So last video I will put some of the advanced foundry technology related topics. Now we will discuss about some of the things in advanced foundry technology. So give good perspective with adequate depth to understand casting metallurgy and design, special casting processes, and including recent advances in casting. So course outline is pattern making, molding, casting metallurgy and design, casting process and special casting processes, melting, pouring and testing, recent advances in casting. So today we will discuss about, already we are discuss about patterns and pattern making. Today we will discuss about molding. So molding, in a traditional process, the molding is made by pouring the sand and rammed it around the pattern. The packing of the sand can also be done by hand or pneumatic rammer, a slinger, jolt squeezing, or squeezing and shooting. There are three types of mold. The type used depends upon the life required. Expandable, single-use type molds, semi-permanent molds, and permanent molds or dies. Molding, the life of the mold is expressed as the number of pouring for which the mold can be used before its destruction. First one, expandable or single-use type molds. It is most popular for foundry practice. Expandable molds are made of natural or synthetic sands. The basic material is silica sand mixed with binder, which is bentonite, polonite, clay with an addition of oils, dextrin, waste sulfide liquor, or a resin. So green sands are sands with moisture content of up to 6% and compression strength of 2 to 8 into 10 power 4 Pascal, and skin dried and dried sands have compression strength above 1 into 10 power 6 Pascal. Semi-permanent mold. Semi-permanent molds are made of highly resistant materials such as chamote, graphite, or plaster. Their life corresponds to several dozens pouring, and for every pouring, only the surface layer of the mold cavity is reviewed. The molds are used only for large and medium-sized castings of simple shape that are manufactured in batches. Permanent molds are dies. Permanent molds are made of cast iron, alloyed cast steel, or copper. Their life ranges from several tens of pouring for steel casting up to several thousands pouring for aluminum alloys. They are used in mass batch production of small and medium-sized castings. The selection of the type mold depends on the number of castings, the dimensional accuracy, and the surface finish required. Essential requirements of sand molds: a good, well-prepared single-use molding sand should have their following properties. Refractoriness, that is, it should be able to withstand high temperature. Permeability, that is, ability to allow gases, water vapors, and air to pass through it. Green sand strength, that is, when a mold is made with moist sand, it should have sufficient strength, otherwise mold will break. Good flowability, that is, when it is packed around a pattern in a molding box, it should be able to fill all the nooks and corners, otherwise the impression of pattern is mold would not be sharp and clear. Fifth one, good collapsibility, that is, it should collapse easily after the casting has cooled down and has been extracted after breaking the mold. It is particularly important in case of core making. Sixth one, cohesiveness, that is the ability of sand grains to stick together. Without cohesiveness, the molds will lack strength. Adhesiveness, that is the ability of sand to stick to other bodies. If the molding sand does not stick to the walls of the molding box, the whole mold will slip through the box. So molding sand ingredients, standard tests have been devised by Foundry man to determine properties of sand. Generally, fresh molding sand prepared in the foundry has the following composition: silica 75% approximately, clay 10 to 50%, bentonite 2 to 5% is as required, coal dust 5 to 10%, moisture 6 to 8%. So molding sand ingredients, core sand has oil as the main binding material. A core gets surrounded by molten metal, which causes the oil to vaporize. This increases collapsibility of the sand, makes it easy to remove the sand from holes in the casting. Other bonding agents can be used in place of clay, phenolic resins, bentonite, sodium silicate, phosphate, etc. Additives, sawdust, kerosene, cement, coal dust, dextrine, etc. are sometimes combined with the mixer to enhance strength and or permeability of the mold. The foundry sand or silica SiO2 or silica mixed with other minerals. They are permanent in molding sand because they impart refractoriness, chemical resistivity, and permeability. Selection of sand, fine round grains, smooth surface finishes can be closely packed, have lower mold permeability, enhance mold strength. Coarse grains allows gases and steam escape. Sand grains are classified according to their shape. Round grains least contact with one another, highly permeable to gases, lack strength, minimum binder requirement. Subangular grains, lower permeability and greater strength than rounded ones. Angular grains have a defined edge and nearly flat surfaces, produce higher strength and lower permeability than rounded ones and subangular one. High binder consumption. Compound grains cemented together such they fail to separate, may consist of rounded, subangular, or angular, or all of them. Requires high temperature to break down. So molding and ingredients, the compounded grains like this, angular grains like this, subangular grains like this, rounded grains like this. In practices, sand grains contains mixed grains shapes depending on origin. A subangular to rounded grain mixer would be the best. Mold making process. Molding making is a very skilled operation. We shall describe step by step the procedure for making molds for a split pattern. Place bottom half of the split pattern on the flat molding board with the parting surface downwards. The coating of the pattern with the materials such as graphite powder, kerosene, or paraffin prevents the sand from sticking to the pattern, and spread facing sand to cover all parts of the pattern up to a depth of 20 to 25 mm. Facing sand is freshly prepared molding sand. Fill up the remaining space left in the molding box with backing sand. Backing sand is prepared by reconditioning the previously used foundry sand, which is always available on the foundry floor. Use the backing sand, reduces the requirement of facing sand, which is quite costly. The sand is molding box is rammed, pressed with the special tool. Removing the excess sand and placing the vents using a venting tool It is a long, thick needle. Make venting holes in the sand, taking care that they are not so deep as to touch the pattern. Turning over lifting the pattern, this molding box will form lower box and is called drag. Repeat operations 1 to 6 per second of mold cope. Place 2 taper pins at suitable places where runner and riser are to be located. Fill up the box with backing sand. Pack in sand with ramming tool. Level sand and making venting holes. So in this drag box, a gate is cut below the location of the runner. In the cope box, the molten metal poured in the runner will flow through the gate into the mold cavity. In case any cores are used to make holes in the casting, this is the time for placing the cores in the mold cavity. 10th one, blowing the mold cavity and gating system with compressed air, assembly of the 2 of molds and clamping. Now the mold is ready for preparing molten metal. So this is the step-by-step procedure for sand casting process. This is mechanical drawing of the component, cope of the pattern plate, drag of the pattern plate, and core boxes, core halls pasted together, and cope readily for sand, and cope after ramming with sand and removing pattern, sprue and razor, drag ready for sand, drag after removing the pattern, drag with the core set up in place, cope and drag assembled ready for pouring, casting as removed from the mold, then heat treated, casting ready for shipment. So this type of end product we are obtained from this part drawing. So sand molding features, they are open riser, vent, pouring basin, flask, sprue, blind riser, core sand, cope, drag, mold cavity, runner, choke, gate, parting line, etc. Sand molding features, the flask supports the mold, pouring basin in which molten metal is poured, sprue through which molten metal flows downward, runner system, channels that carry molten metal from sprue, riser supply addition metal to the casting during the shrinkage. Types of sand molds, green sand mold, mixture of sand, clay and water. Green, referring to the fact that the mold contains moisture at the time of pouring. Green sand mold possesses sufficient strength for most applications, good collapsibility, good permeability, good reusability, and are the least expensive for the molds. They are most widely used mold type, but the moisture in the sand can cause defects in some castings depending on the metal and geometry of the parts. So skin-dried mold, the advantages of a skin-dried mold is partially achieved by drying the surface of the green sand mold to a depth of 10 to 25 mm at the mold cavity surface using torches, heating lamps, or other means. Special bonding material must be added to the sand mixer to strengthen the cavity surface. Dry sand molds, it is made using organic binders rather than clay, and the mold is baked into a large oven at a temperature ranging from 200 degrees centigrade to 320 degrees centigrade. Types of sand molds, oven baking strengthens the mold and hardens the cavity surface. A dry sand mold provides better dimensional control in cast product compared to green sand mold. However, dry sand molding is more expensive and the production rate is reduced because of drying time. Applications are generally limited to medium and large castings in low to medium production rates. Next, no back mold. This preceding mold classification refer to the use of the conventional binder consisting of either clay and water or ones that require heating to cure. They are chemically bonded, no back binders, no back system, include furan resins consisting of peripheral alcohol, urea, and formaldehyde, phenolics, and alkyd oils. They are growing in popularity due to their good dimensional control in high production applications. So, testing of sand molds, molding sands is specified in terms of size and shape of silica grains. It contains the clay content and the moisture content. These are determined as follows: grain size. It is expressed by grain fineness number, which is equal to total product divided by total sum of the percentage collected in each sieve shaker. With the help of sieve shaker, we can able to get the proper grain size. And then grain shape. The shape can be determined by observing the grains under a magnifying glass or microscope. Clay content test are also there. Then moisture content test is there. So bulky, density and specific surface area. Bulky density indicates packing properties of sand, and the specific surfaces area is a measure to roundness and fineness. Acid demand value. This is the alkaline basic matter in the sand, binder or acid in nature. Fineness content. Fineness is portion of sand which passes through a 150 mesh sieve. Loss and ignition. It is a estimation by heating a weighted sand sample for 875 degrees centigrade, cooling, and finding the percentage of loss in weight. So sintering temperature or fusion point, refractoriness of sand determined by measuring the sintering temperature. Evaluation of the following features is also required for controlling sand mix qualities. Mold hardness. It is affected by the proportion of the ingredients in the sand and the degree of ramming. So permeability, it is measured by allowing controlled amount of air to pass through the sand samples. So these are all the strength measurement with the help of testing of the sand. And deformation and toughness. It is also called plasticity of sand. The higher deformation value, a better capacity of mold to withstand hydrostatic pressure, as also to volumetric contraction of the casting. Shatter test, it is measured of sand toughness. Compactability, this test measures the percentage of decrease in height from the original constant level of loose sand. Testing of sand molds and moldability and compatibility are similar terms. High temperature characteristic. The characteristics of sand for high temperature must be evolved. Specimens subjected to high temperature test are evolved for hot compressive strength, hot deformation, expansion, and refractoriness. The patterns, pores and core making. Patterns define the external shape of cast part. If the casting is to have internal surfaces, a core is required. A core is a full-scale model of the interior surfaces of the parts. It is inserted into the mold cavity prior to the pouring so that the molten metal will flow and solidify between the mold cavity and the core to form the castings external and internal surfaces. It should be able to withstand high temperature, the core is usually made of sand compacted into the desired shape. As with the pattern, the actual size of the core must include allowances for shrinkage and machining. Depending on the geometry of the part, the core may or may not require supports to hold it in position in the mold cavity during pouring. These supports, called chaplets, are made of metals with higher melting temperature than the casting metal. For example, steel chaplets would be used for cast iron castings as shown in figure 2.21, and pouring and solidification, the chaplets became bonded into the casting. The portion of the chaplet protruding from the casting is subsequently cut off. So this is the core. This is the core. Chaplets are supported here. Then you will get this type of final product: riser and runner, downscrew, parting line, mold, etc. This diagram will explain what is core, how we can able to place the core. So then you can able to pour the molten metal through the ladle with the pouring cup. Then it can pass on to this one, and this is the core. Here the material is filled. After the filling, open riser is there. With the help of that riser, you can identify fill the materials, and then you can stop the material. Whenever the solidification will take place, that time the shrinkage of material. So that time open riser metal will compensate the shrinkage allowance. So cores and core making, and other approach to support core is using core prints. Core prints are extension of core which rest in the similar extension of the mold cavity, so that core remains supported in the mold cavity without the core falling to the bottom of the cavity. For example, if the pin with the collars had a central hole, the hole could be produced by inserting a core in mold cavity as shown in figure 2.23 here. Okay, pin with collars, and this is the core prints. Core prints are provided, and then if core prints are like that, we can able to fix. Enough for today's class. Thank you very much for your kind attention. Today we will discuss about what are all the types of mold cavity, how we can able to prepare the mold cavity, what are all the patterns, what are all the testing methods for different properties of the molding sand, and how we can able to select the appropriate sand for appropriate molding process. Thank you very much. Any queries, you can able to comment on the comment box. We will discuss in the chat box. Also, continuously support is required for further videos. You can support me, and thank you very much for your kind attention. Thank you.